People with disabilities are all around us. Physical disability, acquired from accidents, diseases or conflicts, affects people across all demographics. With an aging civilization, addressing these challenges is becoming increasingly vital. Historically, society has aided those with physical disabilities through prosthetics, which have become highly advanced. Today, we can build prostheses which are smart, precise and powerful. However, it comes with a cost. Modern prosthetic devices are very expensive, posing affordability and availability issues. This is true especially for rapidly growing children and those in developing countries.
To close the gap between medicine and engineering using advances and knowledge from both disciplines, biomedical engineering was born. By combining engineering skills and extensive knowledge of human anatomy and physiology, it is possible to introduce innovative solutions in medicine, including those individualized to patients. The products developed by biomedical engineers can be produced using many exciting new technologies. One of the most popular these days is 3D printing. Why 3D printing becomes so popular in medicine? This technology allows the creation of objects with complex geometry by layering material upon itself. This means we can now manufacture products with highly unusual shapes. Considering how complex the human body is, 3D printing is a perfect solution for medicine.
The problem with 3D printing is that, however smart and fun 3D printers can be, they don't print by themselves. Someone must first design an object to be printed. Designing personalized prostheses requires significant expertise, time and cost due to the need for custom engineering and medical knowledge. That is why, in my team at Poznan University of Technology, we proposed a solution to this problem. In an interdisciplinary group of specialists, we have developed a system for automated design of customized prosthetic and orthotic devices. Our intelligent 3D models redesign themselves when you upload anatomical data of a patient coming from a 3D scan. Thanks to this approach, we can start 3D printing of a new prosthesis sometimes half an hour after we first meet the patient, also dramatically reducing the costs.
The scanners we use are not expensive, making the system available to even wider group of recipients. We start each meeting with the patient with a short interview, and then we scan the limb at the specially adapted station using two 3D scanners, a stationary one and a handheld one. The whole process doesn't exceed 5 minutes.
In the design phase, we use our own 3D models that automatically adjust to meet individual patients' needs, based on interdisciplinary medical and engineering knowledge embedded into them. This automation reduces the need for specialized design engineers for each new patient, streamlining the process. Of course, sometimes we encounter a patient with a new set of special needs. That is when our design engineers need to step in and create a new solution. But once it's done, we can incorporate it in our models and reuse. The patients can also get to know their devices in a visual-friendly environment. Virtual and mixed reality technologies enable patients to customize and interact with their prosthetic devices before they are made, enhancing the personalization and comfort of the devices.
The received models are loaded into appropriate programs, and we can start the magic of 3D printing. In our laboratory, we use 3D printers, both cheap and easily available, as well as these more expensive professional ones. However, in the case of any printer, post-processing of 3D printed product is not very time-consuming and, above all, it is easy and doesn't require specialized knowledge. It mainly involves removing the supports and covering the appropriate parts with soft foam.
Post-printing, we engage with patients for adjustments and feedback, seeking for new ways to improve or use our designs. Innovations include converting orthoses into VR game controllers, enriching therapy experiences, and expanding the functionality. Over 5 years, our research has aided dozens of patients with affordable, quick-to-produce prosthetic and orthotic devices. We demonstrated the potential to revolutionize prosthetic and orthotic care with simple, cheap, readily available techniques of 3D scanning and 3D printing.
Our discoveries could help potentially millions of people reduce the negative effects of their disability and regain the joy of life.
This is a vision that I hope will soon become real.
Poznan University of Technology.